Hello, I'd like to demonstrate reflection and mirrors. Here I have a basic principle of reflection, that the angle of incidence is equal to the angle of reflection. We're going to take a look at that as it relates to various types of mirrors. We'll start off with just a flat mirror or a plane mirror, and we see that if we have a beam of light come up like this, it'll reflect off in such a way that the angle of incidence is equal to the angle of reflection. Now we measure those angles with respect to a line that's drawn perpendicular to the mirror called the normal line. That's this dotted line here that bisects these two beams of light. So the angle of incidence is equal to the angle of reflection for a plane mirror. That's also true if we have a curved mirror. Here's a shiny surface of a track of some kind here, and here we have a normal line at that point. Here we have another normal line at this point, and we see that at each point where a beam of light comes up, the angle of incidence and the angle of reflection turn out to be equal to one another. Here we have the angle of incidence is equal to the angle of reflection. Here I have a plane mirror, and I have a couple of beams of light coming up, and we see the angle of incidence is equal to the angle of reflection for this beam, similarly for this other beam. If I have a surface shaped like this, a convex surface, and I have some beams of light coming up parallel to what we might call the axis line, then we see that this beam will reflect upward, this beam will reflect downward, as if coming from this point right here called a focal point. Of course, that's a virtual focal point because light doesn't really come from there. Light really comes up here and reflects off here on what we call the front side of the mirror. If I have a concave surface like this, a concave mirror, a beam of light comes up here and reflects downward like this, a beam of light comes in here and reflects upward, and they cross through a point here called the focal point. This turns out to be a real focal point in that both of those rays of light actually pass through that focal point. Now I'd like to discuss the plane mirror or the flat mirror in a little more detail and demonstrate that. Here, this shows a beam of light coming up and reflecting off in such a way that the reflected angle and the incident angle are equal to one another. And to demonstrate that, I want to use this laser here with a mirror. And here I have a plane mirror or a flat mirror, and I'm going to let that laser beam reflect from the surface of that mirror. So as the laser beam comes down, it'll strike the mirror, and then it'll reflect up in such a way that the reflected angle and the incident angle will be equal to one another. To do that, I'm going to turn the lights down just a little bit. And then, at the risk of polluting the air, I'm going to use a little bit of chalk dust here, and I'm going to illuminate this laser beam as the light comes down, strikes the mirror, reflects, and reflects up with the angle of reflection equaling the angle of incidence.